Hi everyone, welcome to my channel. I am Gazahin. Today we are going to discuss about relation, domain, codomain, and the ranges of relation. Let's get started. A relation is a set of order pair. It is denoted by R. Let A and B be non-empty set. A relation R from A to B is any subset of A cross B. A relation R from B to A is any subset of B cross A. Example 1, let A is 1, 2, B, A, B. A cross B is 1, comma A, 1, comma B, 2, comma A, 2, comma B. Let R be 1A, 2B is a relation from A to B. So we can form different relations. The number of possibilities of a relation is to the power of 2 times 2, which is equals to. We can form 16 relation. So from that, we have taken 1A to B. So this is a relation from A to B because the first element is an element of A and the second element is an element of B. But let's say this is R1, but R1 is not, but R1 is not a relation, from B to A, because the element is not an element of B, and also the second element not an element of A. B cross A is A1, A2, B1, B2. So we cross from B to A, okay? A cross B is from A to B. So if we take a relation from this B cross A, any status, we form a relation from B to A. For example, A2, B1 is a relation from B to A. But this relation is but not a relation from A to B, because the first element is not an element of A and the second element is not an element of B. This is a relation from B to A. The first element is an element of B and the second element is an element of A. Example 2, let set A and set B is in this relation from A to B. What's your answer? If you like this video, please subscribe now. Now the answer is no, because these members, okay, are not an element of A cross B. Okay, the order pair 1, 2, 3, 4, 5, 6 is not an element of A cross B. Okay, if this is a relation from A to B, so the members of a relation is must be taken from A cross B. But this 1, 2, 3, 4, and 5, 6 is not taken from A cross B. Domain, codomain, and the range. Let R be a relation from a set A to set B. Then domain of R is the set of X such that X, Y belongs to R for some Y. Range of R is a set of Y such that X, Y belongs to R for some X. Codomain of R is simply equal to set. Example, for this relation, find the domain, codomain, and range. The answer is the domain is 1, 2, 3, 4, all members of A, whereas the codomain is A, B, C, D. The codomain is simply the set of all B, or codomain is the set of all possible outputs, or simply the set B, A, B, C. Why we leave D from a range? because D has no pre-image in A. So range is all members of set B which has a pre-image in A. Example 2. Set A and B is given and a relation from A to B. If R is the set of order pair x, y such that y is equals to 2x plus 3, then determine the domain, codomain, and the range of the relation. So to find the domain, codomain, and the ranges of the relation, first of all, we must list the members of a relation. Now let us list the members of relations. The answer is members of relation are this one, 1, 5, 5, 30. Okay. 2, 7 is not an element of a relation because when we insert 2 we get 7, but 7 is not members, is not an element of B. Okay, so this order pair is an element of R if the first order pair is an element of A and the second order pair is an element of B, but 7 is not an element of B. That means since 7 is not an element of B, so the order pair 2, 7 is not an element of the relations. So the domain is 1, 5, the first entry, range is the second entry, 5 and 30. Codomain is all possible outputs, simply the set B or 5, 10, 30. Example 3, let set A contains 1, 2, 3 up to 9 and set B contain 2, 4, 6, 8, 30. If R is a relation from A to B given by set builder method, relation R contains a set of x, y such that x plus y is equals to 12. Then find the domain, codomain, and the ranges of R says. So this example also the same with example 2. So first of all we must list the members of a relation. After that we can find the domain, codomain, and the ranges of the relation. Now let us list the members of relations. Okay, first to find these members of relation, you can write y is equals to 12 minus x. Then insert the values of x in place of x. Okay, if you insert to 1, for example, if we insert to 1, so 12 minus 1, which is equals to 11. So one order pair is, when we insert to 1 we have gotten 11. Is 1 11 an element of a relation? Not be. This cannot be a members of a relations. Okay, so this is not a members of relation. So that we will continue in this forms by inserting 2, 3 up to 9. So then please pause this video and list the members of relation and find the domain, codomain, and ranges of relations. Okay, so now let us put the members of the relations. So the members of relations are 4, 8, 4, 8, 6, 6, 8, 4. This one. So from this now we can find the domain of relations. The domain of relations are 8, and the ranges 8, 6, 4, and codomain is the codomains are 2, 4, 6, 8, 13 is the set of all outputs. It's all about relation, domain, codomain, and the ranges of relation. If you get this video useful, please like, share, comment, and subscribe for more. Until we meet with another video, bye.